exactly work like that, but whatever, we'll go with it. So how much would it be worth after 1 year? 48,000 is going down by 2. And after 2 years, it would go down to 46. And then it's going to keep going down by 2 to 44, then 42, until after 5 years, it's gone $10,000, gone down $10,000, so it's worth 40,000. Now, does that look linear? Is that making a line? Yeah, okay, so then let's see, based off what we're seeing so far, let's kind of answer 1, 2, 3, 4, okay? Give me a second. Some of you are trying to craft this, and that's great, so I'll give you a second here. Okay, so what we have right here is we have we're asked to find the rate of change. Hey, what did we say a fancy word for rate of change is? Okay, so we need to find the slope, and then we need to write an equation. I want you to work with your neighbors to do that real quick. Talk to them. What do you think the slope would be for this problem? And then let's figure out an equation. What equation is usually easiest for a line? Point slope or slope intercept? Slope intercept. So why don't you come up with an equation in the form y equals mx plus b. I'm going to give you 2 minutes here, so work with your neighbors. And try to come up with that. And what if you don't know your neighbor? Then this is such an easy time to say, hey, what's your name? Nice to meet you. Be my friend. Okay, go for it. If you're totally lost, either call me over or ask somebody around you. And then if you've already got 1 and 2, maybe try to figure out 3 and even 4. I'll give you about 1 more minute, but again, if you're stuck, call me over. All right, 10-second warning. All right, we're going to go to Magdalene. Where are you at, Magdalene? Right here? All right, Magdalene, what did you say the slope was? of like in the last problem, what do we need to add to that? Is it going up or down? So what do we need? Alright, so the slope is negative 2,000. How do we know that? Well, it tells us that it's going down by 2,000. Could you have used some of the dots and used a formula? Some of you did that. And did you get negative 2,000? Yes, great. Let's go to the next one. Okay? So let's go to Mapu. What about 2? Were you able to figure out the equation? What do you guys think? We already figured out the slope was negative 2,000. And the y-intercept is 50,000, so there we go. Pretty good. Now the purpose of this is now we have an equation that can kind of tell us what's going on. So if we say, well, how much will this building be worth in 16 years? Do we have to keep putting the dots down and go one at a time? No, we can actually just plug 16 into this new equation, and then it'll tell us how much that building's worth. Now, v of 0, if we plug in 0, it's just going to wipe out this whole part. What was v of 0? 50,000. We already knew that. That's how much the building's worth, right? But let's do v of 16. We're going to take negative 2,000 and times it by 16. And then add that with 50,000. Okay, what is negative 2,000 times 16? Good job. If I add that with 50,000, what's the difference there? Alright, good job. Were you using a calculator or are you using your brain? It's good practice, right? Sometimes we get over-reliant on calculators, so if you use your brain, good job. Big brain. Okay. Any questions on how we got that? So the building, after 16 years, it's only worth 18,000 each. That's a little scary. Last one. How is number 4 a little bit different? It says solve v of t equals 39,000. We're not plugging something in on that one. What are we doing? There we go. This is the value of the building, and we want to know how long until it equals that, okay? So I guess over here I should have been using v and t's instead of y's and x's, so I apologize. But let's try this on number 4, okay? So we're saying the value of the building is 39,000. And we're going to use our equation to figure out how long until the building, how many years until our building is worth 39,000. So do you see how instead of on this one where we plugged in the time of 16 and got the value, we already have the value and we're solving for t. Alright, so then let's send this to Josh. Where are you at, Josh? Do some algebra for us. We want to solve for t. What would you do here?
You want to get the t by itself.
Perfect. How would you do that?
Leave the 50,000 to the side.
How do I do that?
Subtract 55.
Awesome. Okay. What is 39,000 minus 50,000? Negative 11,000, right? Okay, next one, Josh. So you got that first step. Now what do we do?
Divide by 2,000.
Yeah. Got that negative 2,000. Negatives are going to simplify. And that gives us, anyone? 5.5. 5.5 what? Years. Good job. It's good for us to put it in context. So the question was saying how long until it's worth $39,000, and we would say 5.5 next one I feel kind of sad about, because normally I'd have you get out the TI-84s and we would like graph it and we would do what's called regression. Do you remember in secondary one when you did like lines of best fit? That's like one of my favorite things to talk about because it reminds me of Mario on the Wii. Did any of you play Mario on the Wii? And then there was that one game where you'd have the balloons moving back and forth and you're in the cannon and you try to hit the balloons. And the trick is you have to wait until they make a line and then you go through it. See, isn't that like line of best fit? You with me? Okay. Anyway, that's what it reminds me of. But we're going to do this kind of the non-calculator way. We're just going to not use a calculator, but I'll tell you the answer, okay? All right. Let's move that out. What's your name, Alex? Will you read that for us, please? So we're talking about cereal, right? Boxes of cereal. Did you guys have cereal this morning? No? What do you guys eat? Nothing? Oh, man. All right, well, what we have here is cereal. I don't even know what they're called. They're like Cheerios, but they have like oats on them. I don't know. They're pretty good. Anyway, here we go. We're talking about cereal, and what's going on here? When the price was low, how many boxes were they selling? A lot, but then as the price increased, what's happening? There we go. So as the price of cereal increases, the number of sales decreases. You get you see that relationship? Now the golden question here is that a linear relationship? Does this make a line? If I had Mario in a cannon and these were balloons, would he get many extra lives? Does it resemble a line though? It kind of looks like a line. So what we're going to do is what's called linear regression, where we're going to come up with a line of best fit that's modeling what's going on there, and then we'll use that model to make predictions. Now, do you ever have to do linear regression by hand? When you're in 9th grade, do you remember seeing these problems? Did you have to do it by hand? I hope not. What's the easiest way to do this? On a calculator. And what you would do is you'd go in your lists and make list 1. And then you come over here, go to list 2. And then you'd push some buttons and then it would say, wait for it. There we go. It would come up with the line of best fit and it would say, this is the line that's kind of modeling what's going on there. Now you see how it's pretty good, right? It's going through like here and in between those and that one. Is it perfect? Nobody's data in real life ever perfect. No. But one of the applications of lines is linear regression, where we can now use this equation to model what's going on. If you go back, it says, okay, well, let's predict how many boxes we're going to sell if we lower the price to $2 or if we raise it to $4. So I'm going to split you guys in half. You guys, I want you to take this equation and plug in 2. You guys take this equation, plug in 4. And I want you to figure out how many boxes are we estimating that we're going to sell if we raise or lower the price. You understand what you're doing? You guys plug in 2. You guys plug in 4. These are some complicated numbers, so can you use a calculator on your phone or on your Chromebook? Yes, definitely. Don't try to do this on your own. once you get an answer, check with your neighbor, see if they got the same answer. Alright, I need you guys, put your heads together, come up with a consensus. What was the boxes sold? You guys come up with a consensus. And then someone just shout it out. Alright, $2. How many boxes are we selling if we lower the price to $2? Kimberly, go. Okay, sorry, 42,900. That's a lot of boxes, right? Is that what everyone over here got? Now, is that a guarantee that's how many they'd sell? No, this is just a prediction based off of the data they have here. Now, actually, since we're going outside of the range of data, that's called extrapolation. It's not very reliable, but whatever, we're just going with what they wanted us to do. $4, what do we say here? Let's go to, I want to say church. No. Tell me your name. Moises. Yes, that's right. Okay, what did you get, Moises?
12,186.
12,186? Is that what you said? So that would be a lot lower for the number of boxes sold. So this is a great application of lines is linear regression. Cool beans? Okay. Last thing on here is we were asked to describe the direction and strength of the linear regression. Let me go back. Was this going up or down? Down. Now when we're talking about it, we're going to say, is that a positive or negative correlation? If it's going up, it's positive. It's going down, it's negative. This is going down, so what are we going to call this? This is negative. Now the next thing it's going to ask is, how strong of a correlation is it? Well, if they're really close to the line, we'd say that's fairly strong. This is actually what I would call, it's a strong negative correlation. There's a strong relationship between the price and the number of boxes sold. If it was more spread out, then we would say it's not a very strong relationship. So when we're looking at the next slide on here, it's going to have 4 graphs, okay? This is an example of a strong positive linear correlation because it's going up and it seems to resemble a line pretty well. But notice right here, does that look like a line? Not at all, so we call that a weak, but is it still moving up? So it'd be a weak positive linear relationship, linear correlation. Right here, I have no idea what's going on right there. So that would be, there's no linear correlation, or it would be little correlation. Same thing with these ones. This would be a strong negative linear correlation. This would be a weak linear correlation. And with that, you have everything you need to know for lines. You got through your first lesson. What do you think? You did it. Okay. So I'm going to hand out your assignment. You only have to do the part with the lines. There's a section of quadratics, but we'll do that next time.